Welcome back to our new class of AI, machine learning, data science, and big data analysis. The topic of this class is going to be correlation and covariance and linear algebra for machine learning. Now, you might think, why are we going to need correlation, covariance, and also linear algebra for machine learning? So, to make it clear, or to just give you the short, let's say, term about why is it important, is because when you want to find out the relationship between variables, let's say your data, you have to use correlation and also covariance. Another thing is that whatever data you're going to get as the outcome, that is also known as a vectorized data because that is super accurate. So, to do those mathematical operations with your data, also finding out the relationship of your data, you have to use vectors, matrices, and also dot products. Well, in my previous classes, I've shown you everything that you need to know about Seaborn, Matplotlib, and also a lot of other modules to visualize your data. So, there is a specific algorithm in Python and also for machine learning is that you need to use linear regression, also PCA, neural networks, to make sure to create your machine learning model. So, that is exactly why this class is going to be very important for you if you want to advance more in these cases. So, without any further ado, I'm going to show you a couple of concepts and I'm going to explain a lot of explanation and information about this class before we get into our practical part of this class. So, make sure not to skip any part as it is going to be very important for you in the long run. So, without any further ado, first off, I'm just going to open up a canvas so I can show you the formulas that is going to clear out your concept. So, first things first. Just like I said, this class is going to be very important. Now, if you have no prior experience with these type of things, or let's say these type of processes, it is completely fine. Because I'm going to explain everything and I'm going to summarize it so you can get a better understanding about how you can process your data. So first of all, I'm going to cover up covariance. Now, covariance is basically a process how you're going to operate and measure two variables with the change together. Now, let's say I have a data. Now, another thing that I'm going to do is I'm just going to show it to you over here. So first off, we're going to need a text box and I'm going to paste it right over here. So this is the formula of covariance. Now, what we basically do over here is that we find out like this is going to be on the top, okay? So there we go. This is on the top and this thing should be on the bottom. Now, one thing over here that I'm going to do is I'm going to create a line. There we go. So this line that we have over here is going to be the division, okay? Let's say I'm going to reduce the stroke a bit more so it is easier for you to see. So we have covariance. And also, just like I said, you have to find out the relationship between two data or two variables. Now, two of those variables are going to have either different values or sometimes even the similar value. Now, one thing you can see over here, we have x and y. So x and y is basically the covariance or the variable. So one thing you can see over here is we have this x minus x, and then we have the exponent or whatever there is, and then we have y minus that value. So the top thing or the top part that you can see, x minus x and y minus y, that is going to be your positive covariance because this thing is going to multiply to the top part and also the bottom part. So there's going to be a bit of mathematics over here, okay? So when this variable x and y is multiplied with the top value, that is known as the positive covariance, okay? And when this x and y variable is multiplied with the bottom part, which is n minus 1, that is known as the negative covariance. Okay? So, one thing or the last thing you have to keep in mind is that whatever the value is, but if you get the total answer, or let's say the outcome, to be 0, which is 0 covariance, then you will basically have no pattern and no visualization of data. So, you basically have to go through these formulas first to check if there is any relationship. If there is not, then you won't get any data visualization. Okay? And that is basically covariance. Now, the next thing that we're going to learn or understand is going to be correlation. Now, what is correlation? When you basically standardize this formula or this process, or if I just keep it simple, if you standardize this concept, that is known as correlation. But one thing in correlation is that there's going to be only specific 3 types of data, not variables like this. So the only 3 data that you're going to work with in correlation is going to be -1, 0, and +1. So just like I said, if the answer is 0, there's going to be no pattern or no data to be visualized. But if you get a minus value and a plus value as the outcome, the +1 basically indicates a perfect positive. So that means your data is going to, let's say, work with each other perfectly. But if you get a minus outcome or a minus value after this formula, it is basically known, or the -1 indicates a perfect negative. So both of those data will basically have relation, but it is not going to work together in the best way. Okay? So if I basically just come to conclusion and tell you what is the difference between correlation and covariance, is that when you are working with covariance, it basically depends on this x and y variable. But when you are working with correlation, there is a specific data, -1, +1, and 0. Okay? And also, one thing is that in covariance, this interpretation of your data is kind of really hard because this is mainly used in scientific data. Okay? And when you want to work with correlation, as the data is simple, only 3 values, it is basically very simple. Okay? And when are you going to use both of these? Well, when you are working with PCA, feature variance, let's say in conclusion, scientific data, you are only going to work with covariance. But if you see that there is only one thing that you have to specify or work with, which is featuring the relationship, or let's say the variance of your data, or let's say finding if it is positive, negative, or if there's no data at all, then you're going to use correlation. Now, it might be a bit complex for you to understand right now, but I'm going to go through them step by step. Okay? So, first things first, let's finish up our first thing, or the first part of our class, which is correlation and covariance. So first off, let's open up PyCharm. Now I'm going to create a new project that is going to be exactly the same name. Make sure you are working with 3.12 Python or above. Make sure not to use anything below 3.12. Okay? So just like you can see, I have opened up PyCharm. And you can see my environment has been totally functional. Now, the first thing that we want to do is we want a data set. So first things first, let's create let's say a CSV file. Let's say I'm going to put in example.csv. So in this example.csv, let's say I'm going to put in height, height. Then I'm going to put in, let's say, width. And also I'm going to work with age. So the height is going to be, let's say in centimeters, 160. Let's say the weight or the width of this person is going to be 56. and also the age of this person is going to be 22. Then I'm going to put in, let's say, 167. This is going to be 59, and the age is going to be 21. Here, I'm going to just keep incrementing the data or the value. So the width of this person is going to be, let's say, 60. And this person is going to be 24. Then I'm going to put in like 2 more data. Let's say 175. This person is going to be, let's say, 66 in width. And the age of this person is going to be, let's say, somewhere around 28. 179. And let's say I'm going to put in 81. Or let's say 71. And also, for this person, this age is going to be 31. There we go. So we have our CSV data. Now, let's create a Python file. Let's say CORR, that's it. So we can work with correlation and covariance. Now, to complete this class or to make sure that everything is functional, we're going to need a couple of the modules. First things first, pip install pandas to work with our data. And also I'm going to put in numpy at the same time. So both of these are going to be installed perfectly on your device. There we go. This is how it's going to show up. Now after that, I'm also going to include, or I'm also going to put in Seaborn and also matplotlib, because those things or those modules or libraries are basically going to help us to visualize the data and to find out our correlation and also the covariance. You will see in just a couple of seconds and how you will be able to find the relationship between those data. Okay, let's wait for a bit. Just make sure you are connected to the internet. There we go. We have numpy and we also have pandas. To give it another check, I'm just going to go off to interpreter settings. And as this opens up, we have pip over here. And first things first, I'm going to type in import, let's say, pandas as PD. I'm going to import numpy as NP. There we go. So we have both of these. I'm going to make sure to also run this exact same code over here to just update our pip version. Okay. Now, as we have pandas and numpy, we're just going to wait for a bit, and then I'm going to type in pip install Seaborn. So we are going to use Seaborn and also matplotlib at the same time. There you go. You can see it is going to install a couple of packages, which are basically the font tools. So just wait for a bit until it shows up, and then we're going to also install matplotlib on our device. There we go. It has been installed. I'm going to type in pip install matplotlib. There we go. So we also have matplotlib installed on our project. So as this is done, I'm also going to import Seaborn as SNS. I'm going to import matplotlib.pyplot as plt. Now, the first thing that you want to do is you want to load up the data. So data frame equal, then put in pd.readCSV, open up the parentheses. Let's say I'm going to put in example.csv. Now I want to print out my dataset. Dataset info. Also, I'm going to print out the data frame. Now, first off, let's run the program. That's what you should obviously do all of the time to check if your data is printed or not. If your data does not print over here, then it means that it cannot find the dataset and it cannot be processed. Now, after this one, or after this step, this is exactly where I'm going to show you both of the matrix, which is covariance and also correlation. So first things first, I'm going to show you covariance. Just like I said, it is going to depend on the variables. Now, one thing inside this data set is that there are a couple of variables. even though this is one data set, there we have height as a category, width as a category, and also age as a category. So I'm going to put in covariance matrix. It's going to be equal to df dot, just put in COV. Whenever you want to find out the covariance, just type in .cov. Now, I want to print it out, double quotation slash n covariance data matrix. So we have this covariance data matrix, and then I'm going to print out cov matrix. If I run the program, you will see something will be printed over here. And you can see everything has been given in such a way it looks like almost a spreadsheet, or let's say a table. We have height, width, age over here. We also have height, width, and weight, age over here. So that is going to be our relation of our data. Now, even though we have specific data applied, nothing is going to show up yet. Because if you want to work with it, you basically have to visualize it using Seaborn and also Matplotlib. So we're going to go through that later. Now, the next thing that I'm going to show you is going to be the correlation matrix. So I'm going to put in correlation matrix is going to be equal data frame dot and put in CORR. So CORR for correlation and COV for covariance. First off, I'm going to print it out, backslash, double quotation, backslash, n. Here I'm going to put in correlation data matrix. Here, I'm going to print out the correlation matrix. If we run the program in the same way, you will see this is exactly how it will print it out. Even though you can see over here, we have a lot of different type of data, such as we have 1, we have 0, we have 0 over here, 0, 1 again, 0, 0, 0, and 1. So 3 of the data is going to be perfect positive, and most of them are negative values. Now, perfect negative is this one, which is on the first index. Or let's say, not this one, but the other ones are on 0, but not perfect. Okay? Now, to find out the relationship between both of these data and to work to process our data, we have to use, let's say, plots. So I want to use Seaborn to make sure to visualize the data. So plt dot figure. Now the figure, I have to define the size of the figure. For that, I'm going to type in fixed size. And the first thing that I want to put in over here, parentheses, let's say 6, 4. Now, even though if you want it to be bigger or smaller, it's basically up to you, but I'm just going to use this data. Now, this is where we put in our Seaborn. So sns.heatmap. First off, the first data that I want to use is going to be the correlation matrix. So correlation matrix, comma, and then you're going to type in anot equal true. After this, I'm going to make sure to put in a title. So in the title, I'm going to put in, let's say, correlation matrix relationship visualization. There we go. So we have the visualization of this data. Now, the next thing that I want to do is I want to save the figure as, let's say, an image format. So I'm going to type in plt.savefigure, open up the parentheses, double quotation. Here, let's say, I'm going to put in correlation dot, let's say I'm going to put in PNG. Now after that, first off, I want to show the data too. So put in show. So after this, you just want to run the whole program. Now, if it shows you off as an error, then it means it is not working. But if it shows you out something like this, there we go. So the correlation matrix relationship visualization is over here, such as we have 1, 1, and 1. So all 3 of these are basically the perfect positive value. And the other ones are all of them negative value. Now, if you also want to work with, let's say, covariance, you can also work with it. So instead of correlation, you just type in covariance. And let's say I'm going to put in covariance in the same thing, covariance. Now you can run the program just like this, and you will see we're going to have data like this. Now, one thing that I have explained to you at the beginning is that covariance does not work with only 3 values. It is basically infinite. It could be minus infinite, it could be positive or plus infinite at the same time. And there is just 0 at the middle. So this is exactly how you can find the data or find the relationship of your data, which is going to be completely positive or negative. That is going to depend on the data set that you have. Now, one thing you can see over here, there is 42 2 times. That means there is going to be a good relation between these two data when these are combined together. And that is basically how Python and these libraries are going to find out the relationship between your data. There we go, we have 24, 24, 27, 27. There's no 54 over here, but we have 36, we have 18, which are basically only singular values. So this is exactly how you can work with correlation and also covariance. Okay, so hope you understood about covariance and also correlation. Now, let's move into the next part of this class, which is going to be linear algebra using NumPy. So NumPy is basically going to have a very important, let's say, influence in this part of the class. Okay, so just like, correlation and covariance, there are also some, formulas that you have to understand. Now, in the same way, you might think, why is it important in, machine learning? So in machine learning, there is going to be a couple of operation. Now, if you've seen my classes up till the very beginning, up till now, you know that in Python, there are different types of operation. There is arithmetic operation, there is comparison operation, there's Boolean operation, and so on. So in machine learning, there are also a couple of operations. And those are, let's say, vectors, matrices, matrix multiplication, dot product, transpose, identity matrix, and also linear transformation, which comes from linear regression. Okay, so how these operations help is basically using neural network, which basically multiplies your matrix and your data, just like we've seen on the figure. It basically multiplies the data and predicts and finds out more possibility of matching up more, giving you out more positive or negative value, or giving you out something, let's say, with no pattern, something like that, okay? Then if you want to find out, let's say, a normal equation, such as, let's say you want to find out positive values, that is exactly where linear regression comes to help. It basically gives you out a couple of data in such a way where all of them are going to be, or most of them are going to be connected and give you out an equation. Then you can work with engine values and also engine vectors, which is basically used in PCA. Well, you don't need to go into all of these complex concepts, but you can obviously understand and know more about it. Then there is also another operation, which is known to give more space to your vectors. Now you can see, or you will see sometimes, that there are going to be a couple of data with, let's say, 0 and, a lot of decimals or a lot of decimal values, which can be almost quite similar or identical, but at some point there is one different value. So if you want to give out more space to your data to find out more differences and to find out the, let's say, intervals between them, you basically use SVM, which is also done by using linear algebra. Then if you want to, let's say, find out pixel matrices, what you basically do is use a process called computer vision. So all of these things basically help you to create your machine learning model to predict more and find out more data and multiply them. So the most important thing that we're going to learn in this class is going to be the vector and the matrix. So, vector can also be termed as a list of data, and matrix is basically known as, let's say, double-sided or 2D list of data. Okay? So basically how it looks like is, let's say I'm going to create a text box. Let's say I'm just going to draw it over here. Okay? I'm going to reduce the weight a bit. Let's say I have a variable. Now in vector, it is basically used by something like this. V, our vector, is going to be equal to the secondary bracket, and then you can put in your data, 1, 2, 3. So this is basically your vector data, but this is going to be immutable. So these data cannot change, you cannot replace it, neither you can modify it. Then we have the matrix. Matrix is kind of like, let's say, a range of data, but it is basically defined by A. So A is going to be equal to secondary brackets, and let's say 1, 2, 3, and also 4. So that is exactly how you define your matrix. And the next thing, which is, let's say, optional, but you can learn this too. Now, even though when you follow these formulas or these type of syntaxes, basically what it combines up together is, let's say, a dot product. So how is a dot product used and where is it used? So the dot product is basically also a type of visualization of your data. Okay, I'm going to put it right over here so it is just easier for you to see. I'm going to just reduce the size just like this. There we go. Okay, so the dot product is the visualization of data, but it is basically used in neural network to multiply your matrix, cosine similarity, which is also, let's say, to give more space to your vectors, and also gradient calculation. Okay, and this is basically defined by using A, which is your matrix, and then we have B, which is your secondary variable. Now this is basically equal to, let's say, I'm just gonna make sure to undo this, lambda, and then A, then we have the constant value, B, and then we also have the constant value. Okay, so this is basically how you go through the process of multiplying your matrix. But this is just the base part to find out the variable and the result, which you can use to actually multiply your data. I'm going to group it together. I'm going to keep it right over here. Okay, so here I'm just going to also group it together. I'm going to group this together too. Okay, now the last process to actually multiply your matrix, which is the range of data, which is basically done through prediction or the information that is going to get through the data set. So basically, there is a specific rule of multiplying your matrix, which is inner dimensions need to match. Okay? Now, what is inner dimension? Now, obviously, when you worked with data or even mathematics, let's say in parentheses, let's say I have two parentheses. Now, both of them are multiplication. 2, let's say, into 1, and 3 into 3. Now, which one do you think is the inner dimension? The inner dimension is basically the 1 and this 3, because this is more in the middle. Okay? And another thing is that when you are working with matrix, there cannot be a vast amount of data. Basically, you're working with two data or two variables, and then you're finding out the relationship. Okay? So there's not going to be a lot of data when you work with, machine learning model and also multiplying your matrix. Okay? So these two, 1 and this 3, this one is basically the inner dimension, and both of these need to match. Just like you can see, the first one we have is 1, and on the next parentheses, it's starting with 3. So it will not work. Okay? So this is basically defined by C, which is the, let's say the multiplication of matrix, equal to a variable, which is vector, and multiplied with B. So this is the exact formula of matrix multiplication. I'm also going to keep them grouped up. I'm just going to keep it right beside this. Okay? Now, what are we basically going to do using all of these things? So, in this class, I'm going to compute the covariance. I'm going to find out the correlation. I'm going to visualize both of these data, correlation and covariance. And the next thing, or the most important thing, is that I'm going to show you by working with vector, matrix, dot product, and also multiplication. So let's open up PyCharm and let's get started with this part of this class of, let's say, linear algebra. Okay? Now, another thing is that, just like I said, there's going to be only two types of data. So first off, let's create a Python file. So I'm going to put in COVV. Okay? So both of these files are a bit different. So first off, I'm going to import numpy as np. Now I'm going to create the vector. So vector a, va, is going to be equal to np dot array, open up the parentheses, secondary bracket. Let's say I'm going to start off with the most basic one, 1, 2, 3. Then I'm going to put in vb is going to be equal np dot array, open up the parentheses, secondary bracket. Here, as we have 3, I'm just going to put in 4, 5, 6. Now you can put in any random number. That's basically up to you. Now let's print out these variables. Let's say vector 1. Here, I'm just going to print them out, VA. And in the same way, I'm going to type in vector 2, colon, is going to be VB. So we have both of these data. So let's just print them out first. So we have those data. Now, we're going to work with dot product. So to find out the dot product, we need a variable. So dot, just type in dot, equal np dot, that's it. Now, va, comma, vb. Now let's print it out. Let's say dot product of our variable 1 and 2. Here, just type in comma and type in the variable dot. So run the program, and there we go. We have the dot product, which is 32. So we have another variable that we basically need. Now, let's create our matrix. Not the matrix, but the matrix. Okay? So, the matrix is going to have A and B. So, A is basically going to be equal to np dot array. So, open up the parentheses just once and put in 2 secondary brackets. First off, I'm going to put in 1, 2. On the next line, do the same thing, secondary bracket, 3, 4. There we go. So we have our first array of data. In the same way, let's say first off, put in the parentheses. Here, B is going to be equal to np dot array of data. Open up the parentheses, secondary bracket 2 times. Here I'm going to put in 5, 6, secondary bracket, 7, 8. So this is going to be my matrix. Okay, so now let's print out the matrices. Print out, let's say double quotation, matrix of A. Here just type in A. And I'm going to print out, let's say, matrix of B. Type in B. Now, as we have found out our matrix, and also our vector at the same time, you can see we have 1, comma 2. This last indices might be integer or slices. Okay, so what we're going to do, we're going to check out line number 12. So here I'm going to put in comma over here, just like this. Now we can run the program again. And there we go. We have matrix of the data, and we also have our dot product of our vector. Now, as we have these data to be found out or done, this is exactly where we're going to multiply our matrix data. So, just like in the formula, which is C equal to A into B. So type in C equal NP dot type in mat mil. Okay, so matrix multiplication. So first is A, comma, and the second is B. So if I want to print it out, let's say I'm going to put in multiplication of matrix value, or I'm going to put in outcome. That's it. So put in comma and define in C. Run the program, and there we go. We have the multiplication of matrix, which is 19 and 22, and we have 43, 50. That is the value of C. So our matrix has been basically multiplicated. Okay, now you can also transpose the data, which is basically done by A underscore T equal A, and then put in dot, just like this, and put in T. So this basically transposes your data. So if I want to print it out, we basically put in, let's say, transposed data of A, comma, A underscore T. And also, as we have transposed the data, the last thing that you have to basically do is also identify it. So I is going to be equal np dot I. Okay, so it is basically going to identify it. So there are 3 data. So I'm going to put in 3, and then you basically type in print and identifying matrix of the data and multiplied variable. Okay, or you can put in multiplied matrix, comma, and here I'm going to type in I, which is the variable. If you run the program, you will see it has identified it. So basically we have 0, 1, 2, 3, 4. So we have 4 non-visualized data, and 2 of them we have positive data. We have transposed data, which is 1, 3, 2, 4. We have multiplied matrix, and all of them are basically just like this. Okay, so the summary of this class is that you have learned how to run linear regression and basically the actual foundation of, let's say, preparing your machine learning model. And these data that we have, just like you can see, we have transposed, we have multiplied matrix, is basically the data that you need to prepare your model. And these are the data that is basically predicted and possibilities of the data or the variable or the vector. Okay, so basically in the summary is that you basically have created an array of data that has been, let's say, pre-processed by Python and also the libraries to create this variable into your learning model. Okay, so thank you for watching this class up till the very end, and hope you understood about everything in this class. If you still have any confusion or any question about any part of this class, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our class projects of this course.